All right, so exercise 3 is much more like what you're going to see on the exam. Because, like I said, it has the little help section right here where I ask you to describe the distribution. This is to make you go to the formula sheet and grab the correct mean and standard deviation. So exercise 3 says a rental car company has noticed the distribution of miles customers put on rental cars is right skewed. Okay, interesting. We've never seen that before. The distribution has a mean of 60. So nothing in here to say this isn't the real deal mean. So we're going to say this is mu. And a standard deviation of 25. A random sample of 120 cars is selected. So as soon as you see this, this is when you should immediately be thinking this is probably a sample mean question. I probably need to do that weird thing where I divide my standard deviation by the square root of n. And then as we move on, we can see, sure enough, it is. Because we have described the sampling distribution of the average for our sample. So that's what we need to be describing, which is our x bar. Distribution tells me that I want to say what is that following. We really only have two distributions in this class, binomial and a normal or approximate normal. And in this case, since we started out right skewed, we have approximate normality instead of true normality. And then the only other thing we got to do is go figure out our mean and standard deviation. Since we're talking about x bar, the mean of x bar is the original mean, so we'll just toss our 60 in there. And our standard deviation of x bar, well, that's the original standard deviation divided by the square root of n. Like I said, that's going to come in handy. So 25 divided by the square root of 120. Grab my calculator. 25 divided by, divided by the square root of 120. 2.2822. All right, so this is supposed to give us the thing of like, okay, let's get rid of that. We're using this in the next question, of course. So the next question says, what is the probability? Okay, we know we're looking for the area under a curve. Probably going to use that help question I just had you guys do. So let's put our 60 in the middle. That the mean number of miles for our sample of 120 is less than 54. So again, we're looking for the probability that our sample mean is less than 54. And this is our distribution of sample means. We can go ahead and use all of that information. 54 is our cutoff. We want below. And this is just a straightforward normal CDF question. Negative E99, 54, 60, 2.2822. Not getting distracted by that other standard deviation because I crossed it out and I know that part A was there to help me. So I'm going to go type this in my calculator. I suggest you pause, try the next question on your own. It's tricky. See if you can figure out the trick to it, and then come back and watch the rest. All right, so our last part here is still looking for a probability, right? So we're still going to be looking for an area under a normal curve. But this probability is not about our sample mean. So if I drew this picture, I'm going to find myself in trouble because we're looking for the total to exceed 7,400. And we don't necessarily have a way to write total. If you're really classy, you could use the summation notation, but we don't really use that very often. So I'm just going to write the word total, and exceeds is a greater than. So that's the probability we're looking for. And we can't really draw that on our curve because our curve is centered at 60. Now we could use all that complicated mathy stuff that I ignored at the very top about how we can find the mean and standard deviation of a sum of random variables. Or we can be more clever than that. The way you calculate a mean is by taking everything up, adding it together, getting a total, and dividing by n. So if I divide this by n, I effectively are going to convert this to an x bar. And our n is 120. So all I need to do is figure out what the heck 7400 divided by 120 is. Because if we exceeded 7,400, that means the average car did more than 61.6667 miles. Oops, I need a greater than. 61.6667. I'm going to keep my 4 decimals just because I don't want my z-score to be off, or my normal CDF to give me a value that's not correct. So now I have a cutoff for a value that makes sense to draw on this curve. 61.667. That makes sense. Exceeds is still over here. And then we could use our normal CDF, starting at our 61.6667, going on forever to E99, using the mean and standard deviation for a sample mean, because we converted everything to that context. It is possible to go figure out the mean and standard deviation for a total, but like I said, that is mathier than I get in this class, and it's a heck of a lot easier to just convert our total to a sample mean. And that value ends up being 0.2326.